Good day and welcome to the Math Salon. I'm Dr. Anamendem. We are going to look at two advanced level questions on roots of equations and discriminants. So the first question says, given that one of the roots of the quadratic equation 2x squared plus bx plus q is equal to 0 is twice the other, show that b squared minus 9q is equal to 0. In order to do this, we have to remind ourselves about quadratic equations. So a quadratic equation of the general form ax squared plus bx plus c equal to 0, if it has two roots alpha and beta, then the sum of the roots alpha plus beta will be equal to minus b on a, and the product of the roots will be equal to c on a. So we'll try to apply the idea here. So this is our a here, this is b, and this is c. For this equation, we are told there are also two roots, alpha and beta, say. But they say one of them is twice the other. So let's say beta is twice alpha. So then alpha and 2 alpha would be our roots. So the sum of the roots will be alpha plus 2 alpha. And we are told that is minus b on a. So that is minus p divided by 2. Alpha plus 2 alpha is 3 alpha. And that's minus p on 2. So alpha is dividing both sides by 2. You get by 3, you get p minus p on 6 for alpha. So let's look at the product of roots. So alpha times 2 alpha should be equal to c on a. That's q divided by 2. Alpha times 2 alpha is 2 alpha squared. And that's q on 2. If I divide both sides by 2, I get alpha squared is equal to q on 4. But alpha here is minus p on 6. So I can just substitute it inside there. So that is minus p on 6 squared is equal to q on 4. If I square that, the minus becomes positive, and I get p squared divided by 36 is equal to q on 4. I can multiply the left and right hand side by 36. Then 36 goes off here, and I get p squared is equal to q on 4 times 36. 4 here, 1, 4 then 9. That means p squared is equal to 9q. And I can take it to this side, and it becomes p squared minus 9q is equal to 0, as required to show. Excuse me. Second question says, find the value of t given that the equation this has double roots. We already saw in one of my earlier videos that the discriminant tells you how the roots are, if they are real and different, real and equal, or imaginary. And the discriminant was taken from the general quadratic equation formula as b squared minus 4ac. So we are just left to show that this is equal to 0 because the roots are double. So if my d now, based on this is my a here. Oh, I have to fix it, you see. A is here, but this has to be combined. It needs to be of this form. So if your equation is not of that form, you can't do it. So let's fix it. So this is t plus 5 x squared. I see x here and x here, so I can factorize the x and work with it as we do in the math salon. So I'll get plus here into brackets 2t and minus 10x. And this is a constant with respect to x, so I take it to this side, it becomes minus 9t is equal to 0. Here now we have our a here, b here, and c, and we can apply our discriminant. So this is supposed to be b squared minus 4ac. So my b is this, so that is 2t minus 10, all that squared, minus 4. A is this one, that is t plus 5. C is minus 9t. This should be equal to 0 because the roots are double. So now we try to expand this. To expand this, I take the first term squared, that is 4t squared. This times that is minus 20t times 2, so minus 40t. And the last one squared, minus 10 squared is 100. If I take this out, I just see that, for example, that minus 4 times minus 9, that is you are going to get a plus 36t into t plus 5 is equal to 0. Rearrange it once more. So this is 4t squared. If I multiply this out, this is 36t times t is plus 36t squared plus 40t. Sorry, minus 40. That's minus 40 there. And 36t times 5 gives me 180. 180t. And then there is 100 there, plus 100 is equal to 0. Fixing this well, 4t squared plus 36t squared is 40t squared. Is it minus? It becomes plus. 180 minus 40 is 140. T plus 100 is equal to 0. And if I arrange it a bit, nicely, once this, I can divide all through by 20. Then I'll get 2t squared plus 7t here plus 5 is equal to 0. So now I'm left to solve this equation. 2t squared plus 7t plus 5 is equal to 0. We can use the general quadratic equation formula to solve this. It always works. So t will be equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. This is actually equal to minus b, that's minus 7, plus or minus the square root of b squared, that is 7 squared, that's 49, minus 4 times a times c divided by 2 times a. So 4 times 2 is 8, 8 times 5 is 40. So 49 minus 40 is 9. And the square root of 9 is 3, plus or minus. So my t will be equal to minus 7 plus or minus 3 divided by 2 times 2 is 4. So this means my t will be equal to minus 7 plus 3 on 4, or minus 7 minus 3 on 4. If I do that, my t will be equal to minus 7 plus 3 is minus 4 on 4, and that's minus 1. Or t is equal to minus 3, minus 7 minus 3 is minus 10 on 4. Minus 10 on 4, and that's going to give me minus 5 on 2. So those are the two values of t that were required here to be able to get this equation with double roots. Hope you liked it, and if you did, please thumbs up, subscribe, share with your friends. Bye bye.